Hi everyone, my name is Ani.
And I'm Christina.
And we're going to be doing a few problems from the calculations and compounding course. So we're going to start off with a couple of problems on the Aliquot method. And we're going to start with this problem, so I'm just going to go ahead and read it. A torsion prescription balance has a sensitivity requirement of 4 milligrams. Explain how you would weigh 5 milligrams of hydromorphone hydrochloride with an error not greater than 5%. Use lactose as the diluent. So we already highlighted 3 important numbers. 4 milligrams of our sensitivity requirement, 5 milligrams of our target drug, and an error not greater than 5%. So we're going to start off by finding the least amount that we could weigh on our balance. And we do this with the sensitivity requirement. 4 milligrams is equal to 0.05, which is the same as the 5%, times x. And x is going to be our least weighable quantity. So when solving this, we get 80 milligrams as our least weighable quantity. So conceptually, just think about this as the minimum amount that we could weigh on our balance without going over an error greater than 5%. So literally, if you weigh anything less than 80 milligrams, it's going to come out to a larger error than what the problem is asking you for. So this is literally just the minimum amount that you could weigh on the balance. So next, you're going to set up a proportion. And usually what we like to do, and there's multiple ways to doing this, but usually what I find easiest is to set up my least weighable quantity on the bottom of the left-hand proportion and on the numerator of the right-hand proportion. And 5 is our target drug amount that we're targeting. So basically, what you want to see is what factor multiplied by 5 is going to give us 80. So it's actually 16, and then we're going to multiply the bottom by 16 as well. And this is going to give us the total amount of our mixture. And this mixture contains both drug and diluent, which is lactose in this case. And this numerator, least weighable quantity, represents our drug. So, in the end, to find the amount of diluent that we added, you do 1280 of the total mixture minus 80, which is our drug, is equal to 1200 milligrams of lactose, which is our diluent. Now, conceptually, when you think about this, so let's say I made this mixture, 1280 milligrams of this mixture. If I take out 80 milligrams from this mixture, it should contain 5 milligrams of our drug. And I guess technically 75 milligrams of diluent. But in essence, you're literally getting a small part of this mixture, which should contain our target drug amount. And that's how you solve that problem.
And to do a different version of this problem, because there are multiple ways, originally Ani had used this multiplication factor of 16 to get the 80 value that we see here. But in another version of this, we can do a different method where we would originally have the 80 milligrams least weighable quantity, which I'm going to be writing here. And I'm going to put this also into another ratio formula here, where 5 milligrams is up here, 80 milligrams is here, and 80 is here as well. And X right here is going to represent the total of drug plus diluent. And all we have to do now is just cross multiply these values. So you would get 80 times 80 is equal to 5x. And when you solve for x, you are going to get 1280 milligrams. And again, if we do the subtraction method of subtracting the 80 milligrams here, we would get 1,200 milligrams total of the diluent plus 80 milligrams of drug. And again, using the same method, if we do pull the 80 milligrams from the total of 1,280, we are going to get, let me draw this out, 80 milligrams here. It's going to contain 5 milligrams of drug, which is what we originally wanted. So those are the two different methods you can do. When using the second method of the ratio or the multiplication one, because you are multiplying by factors that are kind of something up to you that you're going to come up with in order to determine what values work with you, the values can range significantly. But overall, if you use the same method, you're going to come up with the same solution that will allow you to pull the correct amount of drug out, but the values will be different.